In level 2, we will be using the properties from level 1 and also adding in a few more. First, the even-odd properties. 4 of the functions are odd. That would be sine, cosecant, tangent, and cotangent. These are all odd functions. Odd functions, if you plug in a negative version of the variable, you end up with a negative version of the function. So if I plug negative theta into sine, I get negative sine theta. Same with cosecant, tangent, and cotangent. Cosine and secant are both even functions, and if I plug negative theta into cosine and secant, I just end up with what I started with, positive cosine, positive secant. So the negative sign just goes away in those. So applying these properties first in the first two examples, when I do cosecant of negative theta, I have to take the negative outside, and that's the same as negative cosecant theta. Now for cosine, since it's an even function, cosine of negative theta is just cosine of theta. And now I'm ready to simplify like we did in level 1. I should rewrite cosecant as 1 over sine theta. So I get negative 1 over sine theta times cosine theta. And put these into one fraction, I get negative cosine theta over sine theta, which is negative cotangent theta. In the next example, secant is an even function, so secant of negative theta is just secant theta. The negative goes away, so I get 1 over secant theta. Tangent is an odd function, so that's going to be negative tangent theta, cosecant theta. And I'm going to take this negative and just move it out to the front, because my whole expression is going to end up being negative. And the reciprocal of secant theta is cosine theta, and tangent can be rewritten as sine theta over cosine theta, and cosecant is 1 over sine theta. Now my cosine thetas cancel, my sine thetas cancel, and I just end up with negative 1. Now back to our other properties. The other properties that we need to know are the Pythagorean identities. These come from the properties of a right triangle. Sine squared theta plus cosine squared theta will always equal 1. So when we're simplifying expressions, if we see sine squared theta plus cosine squared theta, we can replace it with a 1. We can also rearrange that identity. If I subtracted sine squared theta from both sides, I would get 1 minus sine squared theta equals cosine squared theta. So that's another version of that identity. And then I could also subtract cosine squared theta from both sides, and I would get 1 minus cosine squared theta equals sine squared theta. So I should try to recognize this identity in any of those three forms. And with our other two Pythagorean identities, we could rearrange those also. So tangent squared theta plus 1 equals secant squared theta. I could rewrite that one as secant squared theta minus tangent squared theta equals 1. Or I could write it as secant squared theta minus 1 equals tangent squared theta. And then with cotangent, or the next one, 1 plus cotangent squared theta equals cosecant squared theta. Again, we can write that in two other ways. So we could say cosecant squared theta minus cotangent squared theta equals 1. Or cosecant squared theta minus 1 equals cotangent squared theta. And this whole box needs to be, of this whole box of identities needs to be memorized. So we really only have to memorize these three Pythagorean identities, but we do need to recognize that they can be manipulated and they can show up in different forms. Okay, so on to our next example. We need to distribute in part C. So if I multiply cosecant theta times cosecant theta, I get cosecant squared theta. And then cosecant theta times sine theta. And since cosecant theta and sine theta are reciprocals, when you multiply two reciprocals together, you just get 1. So this is cosecant squared theta minus 1. And now I need to recognize that this is one of our Pythagorean identities. Cosecant squared theta minus 1 is the same as cotangent squared theta, which is a simpler way to write that, and that's as simple as I can get. In this next example, we would first write tangent theta as sine theta over cosine theta. And secant theta is 1 over cosine theta divided by sine theta. I can rewrite that second fraction. It would be 1 over cosine theta sine theta. Now I'm trying to subtract two fractions, and to be able to do that I need common denominators. So the denominator in my first term only has cosine, the second one has cosine and sine. So to make them have the same denominator, I can multiply this first fraction by sine theta over sine theta. And I will get sine squared theta over cosine theta sine theta minus 1 over cosine theta sine theta. And then I can combine those into one fraction. So I get sine squared theta minus 1 over cosine theta sine theta. I subtracted the tops and you keep the bottom the same. Now I can factor out a negative on the top expression, and I would get 1 minus sine squared theta. And 1 minus sine squared theta is equivalent to cosine squared theta. So I end up with negative cosine squared theta over cosine theta sine theta. And now I can cancel one of the cosines on the top with the cosine on the bottom. So the cosine theta on the bottom cancels, and I'm going to just cross off the squared because I'll just be left with cosine theta on the top. So I end up with negative cosine theta over sine theta, which is equal to cotangent theta, negative cotangent theta. In the next example, I recognize a Pythagorean identity right away. Secant squared theta minus 1 is tangent squared theta over sine squared theta. And then I'm going to simplify. Tangent squared theta is the same as sine squared theta over cosine squared theta. And this is divided by sine squared theta. And I can cancel my sine squared thetas and end up with 1 over cosine squared theta. If the reason I'm allowed to do that, if we do sine squared theta divided by cosine squared theta and then multiply by the reciprocal here, it would be times 1 over sine squared theta. Those would cancel. We get 1 over cosine squared theta. And 1 over cosine squared theta is secant squared theta. And that's as simple as it gets. And the next one, since I have two fractions that I would like to combine, I'm going to need common denominators again. So I'm going to multiply the first fraction by cosine theta over cosine theta. And I'm going to multiply the second one by sine theta over sine theta. And we will get cosine theta, sine theta as both denominators. So for the first fraction, I have to distribute, and we get cosine theta plus sine theta cosine theta on the top. On the bottom, cosine theta sine theta. In the next one, we have to distribute, and we get cotangent theta sine theta minus sine theta cosine theta over sine theta cosine theta. Next, we'll combine these into one fraction. So we add together the tops, cosine theta plus sine theta cosine theta plus cotangent theta sine theta minus sine theta cosine theta all over cosine theta sine theta. And on the top I have a plus sine theta cosine theta that's going to cancel out with the minus sine theta cosine theta. So that makes the top a little bit simpler. We get cosine theta plus cotangent theta sine theta over cosine theta sine theta. I can rewrite this cotangent theta as cosine theta over sine theta. So I get cosine theta plus cosine theta over sine theta times sine theta over cosine theta sine theta. And these sine thetas cancel. So I just end up with cosine theta plus cosine theta, which is 2 cosine theta on the top over cosine theta sine theta. And then my cosine thetas cancel, and I end up with 2 over sine theta. But a better way to write that without a quotient or without a fraction is going to be 2 cosecant theta.